Hey everyone, welcome to What the Code. In this video, we are diving into the topic that's fundamental to web security and data integrity: encoding, encryption, and hashing. These concepts often get mixed up, but they each serve a unique purpose. By the end of this video, you'll not only know the difference, but also why and where each one is used. So let's get started. Let's understand encoding. It is a process of converting data from one format to another using publicly available scheme. It is used to ensure that the data is correctly consumed by different systems. It is reversible and does not require any secret key. Most important part here is it is designed for data compatibility. Let's understand this better by the use cases. First one, Unicode encoding. There are certain languages which does not have alphanumeric characters but symbols. So encoding is used to ensure proper characters display across different systems. The second use case, binary to text encoding. So let's say if you want to store an binary data like an image in a database that only supports text, then you can convert it into a base 64 encoded data. And this is also used for email attachments such as PDFs or images. The third one is URL encoding. Sometimes in URL, you have some special characters like space or plus. Encoding is used here so that it ensures proper transmission. Fourth one is QR code. You might have seen QR code while paying if through UPI or for some website. So that is an encoded form. You use your phone and the software in your phone decodes the QR code and gives you the website or the payment link for the payment. The next one is data format encoding. We have different format of data, which is like JSON, XML, CSV. So to interchange between systems, you can use encoding so that different systems communicate over the same encoded data format, and then the respective system parse it according to its own need. Following are some common encoding schemes: UTF-8 for general text handling, base 64 for binary data, URL encoding for web addresses, and HTML entities for web content. This is specially used for sanitizing your HTML so that attacks like XSS can be prevented. FYI, I'll be covering the complete XSS attack and its prevention in a separate video. Now let's practically see encoding with an example of base 64 and URL encoding. This is our simple UI where we are going to do two things. The base 64 encoding, where we'll be choosing an image file. Then we'll be seeing the original image, the base 64 and the decoded one. Let's look at the code ones. So this is our index.html file. By the way, the link to the Git repo of this code is in the description. Let's navigate to the important part of the code. The first one being the input itself, which is of type file, and we are accepting images. Second one is the button, which is encode decode, which has on-click function as demonstrate base 64. Let's go to this function. In this function, first we are selecting that element, our input, and the input will give us an array of files. We'll select the first file. Then we are instantiating an object of file reader, which is a web API. And in that object, we are calling the function read as data URL. This is the function which will convert the image into base 64 encoded string. And the second function is onload. So let me tell you how these functions are called. Once the file is chosen, the read as data URL is called. Then it starts reading the file, and once the file is completely read, the onload function is triggered. So inside the onload function, e.target.result will be the base 64 encoded string. So what we'll do is we'll put the source of original image as the base 64 string, and also to show it in the raw string, we are going to store it in base 64 variable. Now let's go to the UI. Now let me choose the file. Let me click on encode decode. So as you see, we see the original image which we selected, and this is the base 64 encoded string. You can see it is a very long string. One more thing, whenever you use base 64 encoding, it will increase the size roughly to 33%. So if you see, the original size is 131 KB, but the encoded string size is 175 KB. Let's also see in the elements, the image. If you see here, source is the base 64 encoded string. Okay, it's not selecting from the path of my laptop. It is a base 64 encoded string. Okay. Now let's see the demo of URL encoding. For URL encoding, we have a simple function. We are taking the input URL param. So we are only going to take the parameter as the input, and we are going to use the JavaScript built-in objects encode URI component and decode URI component to encode and decode it. Okay, let's see this in the demo. Let me put the parameters as hello world. I am Apurv. So if you see here, the encoded string is having %20 wherever space was there. And let me change it a bit. Let's say I have some plus sign. So if you see, it is %2b where it's plus and %20 where it's space. So that's the demo. Now let's understand encryption. Encryption is a security process that converts readable data, called as plain text, into unreadable format, known as ciphertext, using an algorithm and a key. The important part here is it's designed for confidentiality. There are two types of encryption: symmetric, asymmetric. In symmetric encryption, same key is used for encryption and decryption. It is faster, but key distribution is a challenge. In asymmetric, public key is used for encryption and private key is used for decryption. This is slower, but better key distribution. Let's understand the encryption flow better using a diagram. So here first we are going to show the flow of a symmetric encryption process. There are two parties involved, Tony and Steve. Now both parties must first securely share a secret key. It doesn't matter who creates it. Let's say Tony creates it and shares it with Steve. Now secret key is exchanged, but this is a security risk. While sending, someone can intercept it. Okay, so that's the risk. That key distribution is a risk in symmetric process. Then what happens is they generate plain text and encrypt it with the secret key, whatever message they want to send to Steve. They send the encrypted message, and then Steve can decrypt that message using the same secret key. Similarly, he can send some response back using the same secret key, and Tony can decrypt it using the secret key. So that was symmetric flow. Now let's see asymmetric encryption flow. Here you will have to generate key pairs, public and private. Both of them, Tony and Steve, create their own key pair and they share each other's public key. Okay. Now Tony will generate a plain text, encrypt it with Steve's public key and send it across to Steve. Now since only Steve has his private key and he has not shared it anywhere, only he will be able to decrypt the message and read it. And then later he can encrypt the response with Tony's public key and send the response back to Tony. And since only Tony has his own private key, he will decrypt the message using his private key. So this is better because there is no private key distribution, only public key is distributed, which is fine. Let's practically see the demonstration of encryption. As you can see in the UI, we have an input where we'll be pasting our plain text, and then we'll be clicking on encrypt decrypt, which will give us the encrypted and decrypted text back. We'll be doing the demonstration for both symmetric and asymmetric encryption. Let's go to the code. Scroll down to the section of encryption demo. In that you will see that on click we are calling demonstrate encryption method. Let's go to that function. Before we begin the walkthrough of this function, make sure about one thing, that this code will require your server to be running. The server file is included in the GitHub repo. And one more thing is I'll be running it on port 3000. So make sure your server is also running on port 3000. Now back to demonstrate encryption. Here, this is the main part where we are making a fetch call to the API/encrypt endpoint. And what we are getting back is encrypted and decrypted strings. So let's go to the server code. a pretty simple Express server where we are using the crypto built-in module and bcrypt package and CORS package. So if you're not aware of CORS, I have made a detailed video of cross-origin resource sharing. You can check it out. And let's go to the endpoint. Yes. API/encrypt. Here, what we are doing is we are getting the text from the body and we are calling encrypt function. Let's go to the encrypt function. We have a encryption key, which I have given here as a constant. This you should not define it in memory. You should store it in somewhere like HashiCorp Vault and access it via environment variable. But for demo purpose, I have just created it in memory. And I'm also console logging it. Again, never log your secret keys. This is just for demo purpose. And then we are going to call the create cipher IV function from crypto built-in node module. We are passing 3 parameters to it. One is the algorithm, which is AES. Second is the encryption key. And third is the initialization vector. Now, initialization vector is a random string which ensures that the same plain text encrypts to different ciphertext to prevent pattern recognition in encrypted data. Always remember to generate a new random initialization vector for encryption operation. This function create cipher IV will return us a cipher. Now we will call the update function on the cipher. We will pass the text that we want to cipher. We will pass the input encoding. The text was in UTF-8 encoding and the output encoding, which is HEX hex. After that, we will call the final method and pass the output encoding. The final method ensures that no more text can be added to the cipher and whatever is added has to be encrypted now. So that's it for this function. And then we return the encrypted string. Let's take a look at the decrypt function also. This accepts the encrypted string. We call this create decipher IV method of the crypto built-in module. We pass the same algorithm which we used for encryption. We pass the same encryption key as for symmetric encryption. You have to use the same encryption key. And we also pass the same initialization vector that we used to encrypt that text. Now we'll call the update method with the encrypted text and we'll pass the input encoding of the encrypted text. If you remember, we encrypted it using hex encoding. And what will be the output? Output will be UTF-8 because the original text was in UTF-8 encoding. Again, we'll call final method. So make sure that we don't want to decipher any more thing. And then we will return the decrypted text. So let's go back. We called it encrypt on our plain text that we sent from the UI. We called decrypt on the encrypted text. And now we are going to send that back to the UI. Let's start our server code. Okay, our server is running on port 3000. Let's go to the UI. This is my plain text. Now let me click on encrypt decrypt. So this is our original text. This is the encrypted text and this was the decrypted text. Let's also check the secret key which we logged into the server. So this is the secret key. Now let's take a look at our asymmetric encryption function. So in this, we are making a fetch call to a different endpoint API asymmetric encrypt. And we are getting the response and we are again displaying the encrypted string and the decrypted string. Let's go back to the server code. In this API handling, we are taking out the text, plain text, which we want to encrypt, and we are calling the asymmetric encryption function. Let's go to that function. We are using the generate key pair sync function of crypto built-in module, and we are passing the algorithm as RSA. There are a couple of options that we have to pass to this. The first one is modulus length. That is the key size in bits. The higher the key size, the better it is. The 2048 is the recommended size. The next is public key encoding. So here we are giving the SPKI, which is a standard format for public key information. And next is private key encoding. Here we are giving it as PKCS8, which is again the standard syntax for private key information. And The format is PEM, which is a base 64 encoded format. Once the public and private key is generated, for the demo purpose, we are going to log it in our server, but you should not do it. Next, we are going to call the public encrypt method of the crypto module, pass our public key and pass our text as a buffer. Buffer is a Node.js class to handle binary data. Encryption works with binary data, so we have to convert the text to buffer. That will give us the encrypted message. The next we are doing is decryption. We are calling the private decrypt method from the crypto module. We are passing our private key and the encrypted message. And at the result, we will get our decrypted message. We are returning it back. So let's go back to our API handling. Here we are going to just return the public key, the private key, which is not required. So let me just delete it. We'll return our encrypted and decrypted message. We'll have to convert it to base 64 because the thing that was returned as encrypted message was a buffer. Okay. So let's go back to the UI and see the demo. Okay. So same string, but this time this is a different encrypted message and it's longer also. Let's also check the public and private key that we logged on the server. So as you can see, this is the public key and the below one is the private key. So that was the demo for encryption. Let's briefly talk about the best practices for encryption. As mentioned earlier, store your secret key in a safe place like HashiCorp Vault, which you can access via an secure API. Then keep changing your secret keys at certain interval time, just like you would change your own password. Use standard algorithms by following industry standards. Avoid deprecated algorithms and use initialization vectors. Now let's understand hashing. It is a one-way function that converts input data of any size into a fixed size output. And the important thing here is it's designed for integrity checking and it cannot be reversed. Let's check out the use cases. The first one and the most common use case for hashing is password storage. It helps us securely store passwords in database and protect against data breaches. Let me explain how. Assume you did not hash the passwords that the user gave and store it in the database. If by chance there is a data leak, the attacker has the access to the user's username and password. But if you hash the password and then store it in the database, then all that attacker has is the hashes of the password and not the actual password. The second use case is the data integrity verification. It helps ensure that the data hasn't been tampered with. How? So if you take one string and you take the same string and generate the hash, it will be the same. And hence it helps us check whether the string has changed or not. Examples, file checksums and digital signatures. The third use case is data deduplication. Let me give you an example of front-end static files. In our front end, we have files like CSS, there are JavaScript bundles. So if you use and configure Webpack bundler in such a way that it adds a hash at the end. The purpose of that hash is that the browser understands whether if the hash has changed, then there is an update in the code. If there is no change, then it's the same. And hence it helps in caching. The fourth use case is blockchain. It is used to create blocks in blockchain. It ensures data integrity and immutability. Now let's look at some common algorithms. The general purpose ones are SHA-256, SHA-512, Blake2, Blake3. And for password hashing, we use something like Argon2, Bcrypt, PBK, DF2. Now let us take a look at the demo for password hashing. So here we have two fields. One is for entering password and then we click on hash password and it will create a hash of our password. And the second one is where we enter the same password to verify and it will again create a hash and compare the hash. So let's see the code. Scroll down to password hashing demo. Here you will see the two inputs that we mentioned and the important part of the code over here is the hash password function and the verify password. Let's take a look at them. In the hash password, we take the password from getElement by ID and then we send it to API/hash, and whatever response we get, we check the hash and we display the hash. Similarly, for verify password, we will go to API/verify, and it will respond us with a match boolean, whether it matched or not, and accordingly we will show the UI. Let's go to the server to see how it works over there. So for /API/hash, what we will do is we will take the password from the body, and this here salt rounds, it is a random data that is added to the password before hashing. Why? So that it makes identical password hash to different values. If my password is ABC, and if I generate a hash with this salt, and later 10th user has the same password, but his hash and my hash will be different. Now you might think, then how will we decode? How will we compare the hashed password while logging in? It will be done easily because the salt rounds is also stored along with the hash. Next, we are going to call the hash function from the bcrypt npm module that we have installed. It accepts the password, basically the string that you want to hash, and the salt rounds. In return, it will give us the hash string, and what are we doing is we are storing it in our local variable. Usually you should not do this, but for the demo purpose, I am doing this. Usually you will store it in the database. Now let's check out the endpoint /API/verify. We destructure the password. We check if there is no stored hash, then there is no password. And if it is there, then we call the compare method of bcrypt npm package. We'll pass the password to it and the stored hash. It will take out the salt rounds from the stored hash, and it will create a hash of the password with the same salt rounds and then compare with the stored hash. That's how it will match. Now let's take a look at the demo. I'll enter the password, let's say Tony, and let me create the hash password. So this is the hash that gets created, and let me enter a wrong password. I will add Steve, and if I do verify, password does not match because it did not create the same hash. Now let me give it as Tony. Verify, it matches. Now let me show you one more thing. Let's say the 10th user after me who signs up again has same password Tony. Let me create. If you see, the hash changed. If you create again, it will change. It will keep on changing. But you don't need to worry, as the salt will be part of the hash. So while verifying it, it will be verified correctly. So that was the demo for password hashing. After going through all the understanding of encoding, encryption, and hashing, now it's time to compare each of them to have a better clarity. So let's go to the comparison. The purpose of encoding is data compatibility. The purpose of encryption is data confidentiality. And the purpose of hashing is data integrity and verification. This is really, really important distinction. If you know the purpose, all other differences are easy. Now, reversibility. Yes, encoding can be reversed and decoded. Encryption, yes, can be decrypted, but no, hashing cannot be reversed. Is there a key required for encoding? No. Is there a key required for encryption? Yes. One key in terms of symmetric one, and two keys in terms of asymmetric. For hashing, no key is required. Output, encoding and encryption both have variable length, hashing has fixed length. Can it be used for security? Encoding, no, not for security. Encryption, yes, protecting the data confidentiality. Hashing for password storage and data integrity. What are the common uses? For encoding, binary to text conversions, URL safe strings, data transmission. For encryption, secure communication, data storage, file protection. And for hashing, password storage, file checksums, digital signatures. What are the examples of algorithms that are used? For encoding, base64, URL encoding, ASCII. For encryption, AES, RSA, CHA-20. Hashing, SHA-256, bcrypt, Argon2. In terms of performance, encoding is fast, encryption is moderate to slow, and hashing is fast to moderate. It depends on the number of salts. When to use? For encoding, when you need to represent data in a different format. For encryption, when you need to keep the data secret and retrieve it later. For hashing, need to verify data integrity or store passwords. So that's all for this video. I hope you understood what is encoding, what is encryption, what is hashing, and what are the differences between them and how they are used practically. I'll see you in the next session.